And today I want to talk about of the project graphite carbon nitride films formed by spin coating technique for fluorescent sensing of metal ions. My name is Brandon Parga, and good morning, good afternoon, and good night whenever when you are watching this video. Heavy metal ions as copper, lead, chromium, iron end up in bodies of water and enclosed at low concentration. These heavy metal ions are very toxic to human health. Recently, the fluorescent sensing has become an interesting option in order to get the concentration of metal ions. Um, this technique presents high precision and low cost operation. One of the more important materials in these fields is the graphite carbon nitride because presents thermal and chemical stability, high photoluminescence emission, and stability against photo blanching. In this project, we made the C3N4 by thermal polycondensation, and with this material, we made films of the C3N4, and we use these films for fluorescent sensing of some ion metals as experimental produce. First, we use the melamine as precursor in order to get the C3N4, and we use the condition for 4 hours and 5 Celsius, 500 Celsius degree. And then with the material C3N4, we made the fins of these materials, and by spin coating technique, we made a dispersion of the C3N4 in ethanol, and also we use the spin coating technique, and with the films, we use these films for the measures of the photoluminescence analysis for some metals like copper, iron, nickel, and zinc. As a structural characterization, first, in the figure 1, we can see the spectrum infrared of the main functional group of the C3N4 for the primary and secondary amines, and also we can see the functional group so of the carbon nitrogen bonds, double and single. And also in the figure 2, we can see the X-ray diffraction pattern of the C3N4. We can find the two main signal. First signal correspond to plane 001, sorry, to plane 100, and this correspond to repetition of monomeric molecule. And the second signal correspond to plane 002, and this corresponds to the staking sheds of the C3N4. As morphological and optical characterization in the figure 3, same image of the C3N4, we can see the characteristic shape of the C3N4 when we synthesize this material with the melamine precursors. And also in the figure 4, we can see the webs of the C3N4, and we can find this material has activity in the visible region. And with these values, we made a dot plot of the C3N4, and we can find the band gap. This is equal at 2.78 electron volt. This is characteristic of the C3N4, and this is characteristic of the semiconductor material. For fluorescent sensing, in the figure 6, we can find the photoluminescence spectra of the C3N4, and we compare this spectra with the photoluminescence spectra with the C3N4 with the iron ion metal, and we can find the quenching effect for the emission band around 370 nanometers. And also with this value, we made a calibration curve, and we can find in the figure 7 for the first points lost the linearity, but for ultimate points we can find a good linear correlation, and coefficient of determination, this is equal to 0.9455, and in this range correspond to is to 0.12 to 0.27 micromole, and in this range we can find the quantities of the iron ion metal, and also we compare these values with the another ion metals of these values of the intensities at 370 nanometers, and we can find the iron present quenching. As conclusion, we made the C3N4 by thermal polycondensation, and we made the characterization for infrared and X-ray diffraction, and we corroborate its main planes and its main functional groups, and also we can find this conjugate polymer present activity in the visible region, and also we can find particles with microset morphology, and also with this material we made C3 films by spin coring technique, and we use these fins in order to determine iron quantities of the iron ion metal. And also these results are very interesting because with the C3N4 films are an easy way to determine ion metals, and with these films can be recovered and reused for sensing, and this is very environment friendly. And this is my reference, my acknowledgement, and that's all. Thank you for your attention.